Hello everyone. In this video, we will simplify expressions using properties of exponents. This is the second part. I will put the link of the first part in the description box below. So let's take this first example right here. So please remember that this example would make use of the power of a power property because we have some powers inside the parentheses and there's another power outside of it. So this -3 is actually for all of them that's inside the parentheses. So that's the power of a power property. So then we can go ahead and simplify this. The 2 is inside the parentheses, and this is raised to the power -3. And then the x to the fourth is inside the parentheses, and that is raised to the power -3. And then the y to the -2 is inside the parentheses, and that is raised to the power -3. We can simplify this as 2 to the power, that's 2 to the power -3. Because you have a raised to the power 1 and the -3. This is x to the power -12. And this is y to the power +6. Because you have a -2 times -3 is a +6. And then 4 times -3 is -12. And 1 times -3 is a -3. Now, using the power of negatives, we can make this exponent positive. We can do that by flipping the fraction. We flip the fraction, and that would change the negative exponent to positive or the positive exponent to a negative. We don't need to flip this because it's already in positive exponent. Again, our target is to always have a positive exponent, so we don't have to flip that. So in this case right here, if I flip this fraction 2 to the -3 over 1, I'm going to flip it around. That would be 1 over 2 to the third. And that is already positive because I flipped the fraction. And then in here, that would become 1 over x to the power +12. Because again, I flipped it around. The negative exponent will turn into positive. This one right here has an invisible denominator of 1, but I don't have to flip this around because it's already positive. So then I can just go ahead and write y to the power 6, which is on top. So then from here, we can simplify this. We multiply all the ones in the numerator. 1 times 1 is 1, and then we have y to the 6th. So that's y to the 6th power on top. And then 2 to the third is 2 times 2 times 2, which is 8. So that would be 8x to the power 12. And this is the simplified version of this expression right there. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we use both the power of a power property and the property of negatives. Remember that this -2 is for all of the numbers that are inside the parentheses. So that means the 5 is inside the parentheses, and that is raised to the power -2. The x to the third is inside the parentheses, and that is raised to the power -2. And then the x to the -2 is inside the parentheses, and that is raised to the power -2. Now, we can simplify this using the power of a power property. So this would come out 5 to the -2. So that's 5 to the -2. And then this one right here would be x to the 3 times -2 is -6. And then this would be x to the -2 times -2 is a +4. So then from here, we use the property of negatives. So we are going to make these exponents here positive. But again, we flip the fraction. Remember, this has an invisible denominator of 1. Whenever we flip the fraction, their exponent will become its opposite. Since this is negative, it will become a positive. So that would come out 1 over 5 squared. And then this would come out 1 over x to the 6th power. And I am not gonna flip this fraction because it's already positive. We always wanted to have a positive exponent. So I can just keep that as x to the 4th. So then from here, we can go ahead and multiply them across. So that would be 1 times 1 times x to the 4th would be x to the 4th. And then that is over 5 times 5 is 25. And then x to the 6th power. Now, we can still simplify this because there are still x's on top and there are still x's at the bottom. We can actually expand it. So that would be 4 x's on top. So I'm going to write 4x is there over. We have 25 at the bottom, and then we have 6x's at the bottom. Okay, so that's 1, 2, 3, 4, 5, 6. And then what are we going to do now is we partner them up and cross them out. So this is going to get crossed out. So this is going to get crossed out. So the leftover is, now here's the thing. Others are going to think that the leftover on top is 0. Please remember that for every x, there's always an invisible coefficient of 1 in front of it. So that means there's 1 left over on top because we haven't canceled it out. So although it turns invisible, but we need to write that out right now. So that would be 1, which is invisible, over, which is invisible right here. It's not there, but that's 1 right there. And that is over 25. We count the x's left over at the bottom. That would be x squared because you have 2 of them. So this is the simplified version of this expression right here. Did you get the same answer as this? Good, perfect. Now let's move on to the next example here. So we have here this example. We're going to use the quotient property. There are 2 ways to do this. We can actually just use the quotient property right away, or we can use the expanded version of it. But I will show you the quotient property. So in this problem right here, we're going to divide the coefficient. That would be 8 divided by -4 is a -2. And then from here, I am going to subtract, remember, because when we divide, we're going to subtract their exponents. So I'm going to go ahead and write x. That's 5 minus invisible 1. Remember, there's an invisible 1 right there. So that would be 5 minus 1. And then from here, we can go ahead and simplify the y. So the y here would be, again, since we're dividing it, we are subtracting their exponent. So 3 minus 4. So that would be 3 minus 4. So then from here, we can simplify this. So this would come out. So I'm just going to write that down here. So that is -2 x to the, that's going to be 4th power because we have 5 minus 1 is 4. And then the y here is -1. Now, here's the thing. Since we wanted to have a positive exponent, this one messed it up because that's -1. So again, remember the property of negatives. This one is an invisible denominator of 1. When we flip this fraction around, then this -1 will turn into a positive 1. So then this would come out -2 x to the 4th, and then flip it around, 1 over y to the power 1, which is already positive now since we flip the fraction. So then we can multiply them across. -2 times 1 is just -2, and then that is x to the power 4. And then remember, all of these has an invisible denominator of 1. So 1 times y to the power 1 is just y. So then this is the simplified version of this expression right there. Now, I will show you the expanded version because, again, sometimes others would prefer the expanded version because it's faster, or others forget the different rules for, or the different properties of exponents. Then the go-to is the expanded version. So in here, I can go ahead and write 8, and then there are 5 x's on top. 1, 2, 3, 4, and 5. And then there are 3 y's. 1, 2, and 3. And then at the bottom, there is -4, and there's going to be just 1 x. And then there's going to be 4 y's. I will put the y's all together on top of each other so it's faster to cross them out. So then from here, I can cross out this partner x, and this y's here gets crossed out. And whatever's the leftover would be the final answer. So in here, 8 divided by -4 would be -2. And then on top, there are 4 x's. 1, 2, 3, 4. So I can go ahead and write x to the 4th. And then at the bottom, the 4 was already gone because I already divided these two. So 8 divided by -2 was actually 8 divided by -4 was actually -2. So then the leftover at the bottom is just y. So as you can see, both the expanded version or using the quotient property would come out the same answer. So it doesn't really matter which method you would want to use. Now let's move on to the next one right here. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, pause it and check your answer. Okay, so we go over the problem here. we're reducing this fraction. 3 over 12 is actually 1 over 4. So I can go ahead and write that as 1/4. For this, there's, again, 3 goes to 3 one time, and 3 goes to 12 4 times. So that's 1/4. I reduced 3 over 12. Now, using the quotient property, we can go ahead and subtract their exponent, the exponent of x. So that would be x 2 minus 5, because you have a 2 minus 5. Again, we're subtracting it because we're dividing it. And then the y here would be, that's gonna be y, and that's 2 minus 6. And then nothing is left over at the bottom except for the 4. So then from here, we can go ahead and simplify this. This would come out to be, so I'm just gonna write it up here. So this is 1 on top, and then the x here would come out to be x to the negative 3, and then this is y to the negative 4, because you have a 2 minus 6 is 4, and then we have 4 at the bottom. Now it says that we need to have a positive exponent, so then we are going to we're going to make this into positive. Again, in order to make them positive, we are going to move it, or we flip the fraction. So this would come out 1 over 4. This x to the third can be written as 1 over x to the third. And then this y to the fourth can be written as 1 over y to the fourth. Again, once we flip the fraction, because again, this one is an invisible denominator of 1. So we can multiply all the ones that are on top here. So that would be 1 times 1 times 1 is just 1 over 4. And that's x to the third, y to the fourth. And this is the simplified version for this expression right there. We can also show this. Again, I'm going to show you the other method where we just have to expand it and cross out the cross them out. So in this case right here, we have 3. And then I'm going to write 2 x's and 2 y's over 12. And there are 5 x's, 1, 2, 3, 4, and 5. And there are 6 y's, 1, 2, 3, 4, 5, and 6. And then from here, we can simplify this. 3 goes to 3 one time, and 3 goes to 12 4 times. And then we can cross this x's out. That's the only x that we can cross out. We can cross out 2 y's here, so I cross out 2 y's at the bottom. So the leftover would be just 1 on top. So I write 1 over. The leftover at the bottom would be 4. And then there are 3 x's, so I write x to the third, and there's like 1, 2, 3, 4 y's. So I'm just gonna write it that way. So right now, as you can see, both answers are the same. So it doesn't matter which way you would use. You would use the quotient property, or you would use the expanded version and then just cross out those like terms, and then you can still get the same answer. It doesn't really matter. Did you get the same answer as this? Good. Perfect. Now let's move on to the next problem right here. So this time around, we will be using combined properties of the quotient property. We're going to use the property of 0, or property of 0, and then the product property for this. So in this first example that we have, I will give you a tip so it's faster, especially if it's like there's a lot of variables involved, or I mean there's a lot of letters involved here. So the tip here is that whenever you get a negative, because our target is to come up with a positive exponent. Whenever you get a negative exponent, you are going to move it to the bottom. So if the negative exponent is on top, you move it to the bottom. And if the negative exponent is at the bottom, you move it to the top to make them positive. Because again, we wanted to have the positive. So that's a tip. So this x to the negative 2 here should be moved to the bottom to make it a positive. And this y to the negative 1 will be moved up to make it positive. So in this problem right here, once we moved these two, since these are the only ones that are negative, the rest will stay where they are. So this would come out. So I'm just going to rewrite it. So that's 4. This x to the negative 2 is going to go down, so it's gone. We're not going to write it. Y to the third is the one that's on top. And then remember, we move this y to the negative 1 right there. So that would come out y to the positive 1. Because again, once we move it, it will switch its sign. And then z to the, so by the way, this is times here. So I'm just going to put a dot here. So z to the 0, the property of 0 is just 1. So anything raised to the power 0 is just 1. And then at the bottom, we got a 16. And then remember, we moved this x to the negative 2 down here. So I'm going to write it as x squared positive now. Because again, once we move it, it turns, it's going to, the sign of the exponent is going to switch. So then we have another x right there. So I'm still going to write the x. And then the y to the negative 1 has already been moved up. But we are left with z to the second power. And then from here, we can go ahead and simplify this. So this 4 goes to 4 one time, and then 4 goes to 16 4 times. So then the leftover on the top here would be, we get 1. And then remember, when we multiply, we are supposed to add their exponent. So the y here will come out y 3 plus 1. And then we get a 1. So 1 times 1 is just 1. So you don't have to write that. So at the bottom, we're left with 4. And then remember that when their bases are the same, if you are multiplying them, we are going to add their exponents. So that would be x to the power 2 plus, again, remember, there's an invisible 1 right here. So that is 2 plus 1. And then we are left with z squared. So we can therefore simplify this as, we don't have to write the 1. So that would be y to the 4th power, because you have 3 plus 1 is 4, over 4x to the 3rd, because you have a 2 plus 1 is 3, and then z to the 2nd power. And then this is the simplified version for this expression right there. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we are going to make sure that we get a positive exponent. So again, the tip is we move the ones with a negative exponent to the other side. Meaning, if it's on top, we move it to the bottom. And if it's at the bottom, we move it on top. In that way, we can switch the exponent to a positive. So in this case right here, I am moving this x to the negative 3 at the bottom. And then this y to the power 4 will be kept there because it's already positive. Again, we're moving only the ones with a negative exponent. So this one right here is going to get moved up. And then this y to the 7th would be kept there. And this z to the negative 2 will be moved up in order that we can make them positive. So then our expression right now would come out. So the ones on top would be 9. And then this one is going to go down, so we're not writing it. But the x to the negative 4 is going to go up. So we're going to write x to the 4th because it has moved up. And then we have a y to the 4th. We did not move it anywhere, so that's y to the 4th. And we get a z. We did not move the z, but we have moved the z to the negative 2 on top to make it positive exponent. So that would be z to the positive 2. So it's already positive. Again, these are all multiplied, so that we make sure that I put the dot there so we don't get confused with what's going on. And then from here, we are going to look at the ones that are at the bottom. So we get the 4. And then remember, this x to the negative 3 was moved to the bottom. So this would come out x to the positive 3 now. And then y to the 7 was kept there. So I'm just going to go ahead and write y to the 7. And then the z to the negative 2 was moved up, so it's gone. So these are the only left over at the bottom. And then from here, we are going to use the product property. So then we can go ahead and write this 9 and 4. We can't reduce that, so we can just keep it like that. So we have the, we can expand this. So that would be 9. And then there are 4 x's, 1, 2, 3, and 4. And then there are 4 y's, 1, 2, 3, and 4. And there's 1 z. And there's an addition of 2 z's. So I'm just gonna write 2 z's right there. And then from here, we are going to rewrite the ones at the bottom. So that would be 4. And then there are 3 x's. And then there's 7 y. So that would be 1, 2, 3, 4, 5, 6, and 7. So then from here, we can go ahead and cross out these 2 x's. These 2 x's gets crossed out. These 2 x's will be crossed out. These y's will be crossed out. So we partner them up. So we have crossed out everything. So then all the ones that should be crossed out. So the leftover here would be the one on top the leftover on top would be 9. And then we have 1 x left. So I'm just gonna write x. And then we have 3 z's. So I'm gonna write z to the power 3. And then we have 4 at the bottom. And we're left with 3 y's. So I'm just gonna write y to the power 3. And this is the simplified version of this expression right here. You can also simplify it using by subtracting these 2. You can also do that. That should be fine, just like how we did it over here. But I showed you that it should work with the expanded version. This one right here, I did not show you the expanded version. But if you would want to do that on your own, then you can actually still come up with the same answer as this. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!